Welcome friends. In this video, we will learn about how small sample tests are performed in SPSS. First we start with the student's t-test, and student's t-test, the test statistic is given by these, where we are to test the null hypothesis that the population mean is equal to some specified value. Here it is represented by mu naught. For this we require information like sample mean and sample standard error, and obviously the sample size. And in combination, this is the sampling statistic, test statistic, and with the help of the test statistic, this test statistics follows t distribution with n minus 1 degrees of freedom. So given the data, we calculate the value of x bar s, and n is the sample size, and we compute this, and then we reach to a calculated value, and accordingly we generate the p value of the test statistic. And if the p value of the test statistic is greater than 0.05, then leads to the accepting of the null hypothesis. But if the p value is less than 0.05, then we reject the null hypothesis. So this is how we basis of the test, and let us see how we can do it in SPSS. Now let us go into a problem. Let us assume that a particular company wants to make trousers for obese people. It's a ready-made garment company, and this is the master tailor, and the master tailor tells that the average waist size of obese people will be 40 inches. Now we are to find out whether this information is correct or not. And actually the floor manager, instead of relying entirely on the master tailor, wanted to get it surveyed. So he sent some people around and asked them to measure the waist size of obese people whom they get across in the road. Accordingly, the individual go around and they collect the information about the waist size of 10 obese people, and here they are, 48, 42, 43, all measured in inches. Now we are to claim whether this null hypothesis is correct, and this is the claim which is made by the tailor master, whether it is correct or not. And for that we go directly to SPSS. So we type in the observations. There are 10 observations and these are the values. Then we go to analyze, we go to compare means, and then we go to one sample t-test. So these are the clicks that we make in this SPSS data file for performing one sample t-test. So we go to analyze, we go to compare means, and then we go to one sample t-test. Once we click here, accordingly a new small form appears before us, where we have the name of the variables along the left side, and whichever variable we want to test, we pull it in the right side. So this is the only variable that we have currently in the database. So we select it, and then we click here, and as soon as we click here, it comes here as the test variable, and the hypothetical mean, which was 40 inches, so instead of initially it was 0, so we type in 40 here. On doing that, we click on OK, and as soon as we click on OK, we get these two tables generated. Now first table is not so important, but if you look at the second table and we look at the corresponding p value, so this is the corresponding p value. This is the calculated value of the test statistic, this is the degrees of freedom, and this is the corresponding p value. Now you see this p value is more than 0.05. Now as we know that p value more than 0.05 indicates that the null hypothesis is to be accepted. So we take this decision, since the p value of the t-test for mean is 0.352, which is greater than 0.05. So there is no evidence against the null hypothesis. Thus we accept the null hypothesis and conclude that the average waist size of obese people is not significantly different from 40 inches. That means the claim made by the tailor master is retained. Okay, now we go to the next problem. This is a problem of two sample t-test. These are two independent sample t-tests. That means two separate samples, but we want to, based on these samples, we want to compare their population mean. Let us assume that a researcher is doing an experiment of collecting venom from snakes, and alternatively he can also collect venom from the lizards. Now in the process of collecting venom from the snakes and the lizards, he has generated the following data. So these are the amount of venom collected from the snakes, and this is the amount of venom collected from the lizards at one go. So these are measured obviously in ml. So very small amount of venom is collected, and we want to compare whether the average amount of venom collected from the snakes or the lizards are same or they are different in the population. So we consider the venom collected from the snakes average value as mu1 and the average value of venom collected from the lizards as mu2, and then we want to test the null hypothesis that H naught mu1 equal to mu2, whether they are same or they are different. For doing this test in SPSS, this is the test statistic, and this test statistic has two variations. One is when the two sample variances or two population variances are equal, and one when the population variances are unequal. But in this case, obviously, we don't have any idea about the population variance because the population variance is not known to us, and so we use the sample standard error for the purpose of getting an estimate of the population variance, and these are the estimates, as you can see, S1 square and S2 square. Now, so first we want to understand whether we are to go with this formula or we are to go with this formula. That is whether we have to go for pooled variance, as you can see here, or with individual variance estimates. So this is when you do this in SPSS, it will tell the entire story together. Okay, let us have this. So we have divided our data as snakes and lizards. These are our category identification variable. We have coded the snakes as 1 and we have coded lizard as 2. So we have wrote snakes here and lizards, and then the corresponding value of venom extracted in this as the second variable. Now for doing this analysis, we go to analyze, we go to compare means, and we go to independent sample t-test. Analyze, compare means and independent sample t-test. When we do this, we land up here. So grouping variable is the type of the reptile. So we click here and then we click this. So it comes here. And amount of venom extracted, we click and then we click on this button and take the amount of venom extracted in the right hand side of the box, in the top box where it is written test variables. And grouping variables are the type of reptile, we bring it in grouping variables. Now these were coded as 1 and 2, so we need to define the groups because here there are two question marks. So we define the groups and then we pick up 1 and 2. So now you see we have got the reptile as 1 and 2, and then we just click on OK. As soon as we click on OK, these two tables are generated, and here we have this one, and here we see that there are two rows, one assuming equal variances, one assuming that the variances are not equal. Now in this case, you see this is the Lefine's test which tests the equality of variance, and the value is 5.24, corresponding p value is 0.39. indicating that the variances are not equal because p value is less than 0.05. So the variances are not equal. So we come to this second row. But if this value is more than 0.05, then we'll assume that the variances are equal and we'll look into the first row. But here variances are unequal and we'll look at the second row. So here is the value of the test statistic and the p value is this. Now you see this p value is also more than 0.05, much more than 0.05. This means that there is no significant difference on the average amount of venom that is extracted from the snakes and the average amount of venom that is extracted from the lizard. So this is the stage in which we actually identify our null hypothesis to be accepted. So we actually go with the second one. As you can see here, we look at the p value of the second row, and accordingly we get the interpretation here. The p value of two sample t-test for mean is 0.363, which is greater than 0.05, indicating that there is no evidence against the null hypothesis. So we accept the null hypothesis and conclude that the amount of venom extracted from the snakes and lizards on an average do not differ significantly. So this is the outcome of the study. So researcher, if he is interested in the quantity of venom, then he can extract from snakes and lizards, snakes or from lizards, it is up to him. And there is no way in which he can get more either from the snake or from the lizard. So that is the outcome of this test. Now let us look at the third type of t-test, which is called as paired t-test. In a paired t-test, what we do is that we compare the population means of a group of observations whose information or whose data from whom are collected before an incident and after an incident, so that the impact of that particular incident becomes vivid in the analysis, whether the event that we are concerned has really brought about any change before the event or after the event. That is what we are going to study in this particular test. Such type of tests are very useful for checking any type of before after situation which generates data that is continuous type data. For example, it can be very useful in sports in order to understand what is the impact before a training program, after a training program. It can be used in education to understand what is the impact of a particular strategy of teaching to the students that has been introduced by the college or the university. So what was the marks that the students used to get before the strategy been introduced and after the strategy been introduced. It can also be used to understand the impact of say share prices of different companies before a particular incident, after a particular incident. So this type of comparison of any before after situation can be explained with the help of paired t-test or tested with the help of the paired t-test. It can be important in medical science as well to understand what is the efficiency of a drug, or whether the drug had really some impact on the performance of the patient before a particular drug being introduced and after a particular drug being introduced. So this is about the paired t-test. So this is the test statistic, as you can see here, and the null hypothesis for this purpose is to test the average before a situation and after a situation. And so this is t equal to d bar sd by root, and d bar is the average of the difference before and after. As you can see here, average of the difference before and after. So for each of the observation it is computed. So we get di. If there are n number of observations, we will get n values of di, and then they are converted to the average d bar equal to summation di by n, and sd square equal to 1 by n minus 1 summation di minus d bar square. So this is the this is how we calculate sd. Sd here means the standard error of the differences, and that is replaced in this formula, and the entire test statistic follows t distribution with n minus 1 degrees of freedom. So this is how the test is performed. We take an example also here. A beautician claimed that he can bring around remarkable changes in the faces of people who come to him for a makeover. To test, these 10 people were considered. They were judged by an expert before the makeover and again after the makeover in a 10-point scale. So these are the marks out of 10. These are not ranks, but these are marks out of 10. These marks, and what happens here, that some people are going to a beauty parlor to make a facial, to give a facial makeover, and before the person enters into the beauty parlor, then there is an independent judge who is no way related to the beauty parlor or to the researcher. He is independently selected, and he gives a mark out of 10 on the facial beauty of the lady who enters into the beauty parlor before she enters, and after she undergoes the makeover and comes out, she is given another mark. So that is 6, this is 7, this is 6.5. Second lady 6.5 before, 7 when she comes out. Third lady 7 before, but when she came out she rather looked horrible compared to what she used to look earlier, and so the marks has gone down to 5.5. So this is the situation what is happening here in this particular. Now whether we want to find out whether there is a significant improvement in the marks of the ladies before and after the makeover. So for this purpose we have some pictures here also for demonstration. So this is before, this lady, and this is after. Okay, now this is another lady, very famous. This is her facial expression before she was entering into the beauty parlor, and this is after the makeover. This is before, this is after. So these are the situations in which we are actually locked. And so next we go to the slide. So we have these. There is no significant impact of the makeover, that is mu before equal to mu after. That is our null hypothesis. and the alternative hypothesis is actually opposing that there is some impact, mu before and mu after is not the same. Now to do this test, we write down the marks of the individuals as two variables, that is marks before and marks after. In this particular data set, we have only two variables, one is mark before, one is mark after, and so these are the marks. Then we go to analyze, then we go to compare means, and then we come to the fourth option, that is paired samples t-test. Now when we click on paired sample t-test, we will end up here in a small form like this, where we have two variables in the right side, left side, and they are to be pulled. So you can just click and drag, bring the first variable under variable 1, and this is the mark of the subject before makeover, this is the mark of the subject after makeover. So we can bring it in these places, we can click and drag, or we can just click and clicking this button also we can bring it in this side. So once we do this, then we click on OK, and accordingly we get the result. So you look at this, the marks scored before makeover on an average was 5.9 and after makeover was 6.7, but whether that was statistically significant, this increment. So accordingly we look at this and we get the p-value here. You see, look at the p-value, it is 0.76, and this p-value is once again greater than 0.05, indicating that the null hypothesis needs to be retained. So we come up with the interpretation of this test that the p-value of the paired sample t-test for mean is 0.076, which is greater than 0.05, that is p-value at 5% level of significance p-value, indicating that there is no evidence against the null hypothesis. Thus we accept the null hypothesis and conclude that there is no significant impact of the makeover on the subjects who went for the went to the beauty parlor. So this is the conclusion that we take. Here you may see that the difference is a little bit high in the higher side, or after the makeover the marks has increased, but that increment is not statistically significant. It can be attributed to fluctuations in the sampling or for the sampling error. So these are three important small sample tests that we had seen today. One is single sample t-test, which is called as the student's t-test, then is independent sample t-test, which is popularly called as the Fisher's t-test, and at last we have seen the paired sample t-test, which helps us to compare a before and after situation. Thanks for watching this video.